This video will show you how to downscale data by shape input. Our first step is to add sites to the map in one of two ways. You can either draw an area of interest on the map, or you can upload a shapefile. A valid shapefile is a GeoPackage file or a zip file. This is an example of a valid zip file. I'm going to use an uploaded shapefile of Northern Vancouver Island. Step 2 is to click on Choose Downscale Parameters. Let's start with Observed Climate Data and choose Observed Periods. The reference period 1961 to 1990 is always included by default, but I will also include 2001 to 2020. Unlike map point input, you cannot specify observed years for shape input, as it creates too many raster layers for the app to downscale. If you need this functionality for shape input, we recommend using the Climber R package directly, which is linked in the About tab. Moving on to simulated climate data. You can either use our recommended default settings, which includes our recommended 8 model GCM ensemble, SSPs, and GCM periods, or you can choose these individually. I will use the Access ESM 1.5 as my GCM, SSPs 245 and 370, and GCM periods 2021 to 2040 for more current projected data, and 2061 to 2080 for farther in the future projected data. Again, unlike map point input, you cannot specify GCM years or the maximum number of model runs for shape input, but this functionality is available directly through the Climber R package. This app will use the ensemble mean. Moving on to choosing climate variables. These are organized into packages of monthly, seasonal, and annual variables, or you have the option to choose custom and select individual elements and seasons. If you select no variables, the app will default to choosing monthly maximum temperature, minimum temperature, and precipitation. I will select degree days above 5 degrees Celsius and precipitation as snow in the summer and the winter. If you're unsure about any of the climate variable abbreviations, please refer to the definitions section in the About tab, or you can click on the blue hyperlinks and this will take you to the relevant About pages. You can also choose to apply an elevation adjustment to precipitation values when downscaling. After choosing your downscale parameters, click Apply. Step 3 is to click on Choose Output Preferences. Since the input is a shape input, you can choose either a GeoTIFF or a CSV file as the output. Let's choose a CSV output first. Choose the resolution you would like to output. The finer end of the resolution scale is based on how many parameters you want to downscale and how big your selected area is. So the more parameters or the bigger the area, the coarser the resolution available. Since I have only chosen a few combinations for simulated climate data, fine resolution is available, but I'll downscale at the default, 2500 meters. Click Apply. Step 4 is to click on Generate Results. This process can take some time, so we thank you for being patient. After the downscaling is completed, a preview of the CSV file will appear in the control panel. Click on Download Downscaled Data to download the zip CSV file. Now let's choose a GeoTIFF output. Again, click on Choose Output Preferences and choose the resolution you would like to output. I will choose the highest, 250 meters. Choose whether or not to include the corresponding elevation map in the results and click Apply. Click on Generate Results. The blue boxes let you know what's happening underneath the hood and when the downscaling process is completed. This process can take some time, so we thank you for being patient. After the downscaling is completed, the downscaled raster layers will be available to preview on the map. Let's start with observed data. We can preview degree days above 5 degrees Celsius, abbreviated as DD5, in the summer during the observed reference period 1961 to 1990. Please note that for all ratio variables, you can apply a log transform to the preview. We recommend applying this as it shows the overall pattern of the data more clearly. Click on Preview Raster Layer. Please note that the map is not reactive, so you must click Preview Raster Layer after changing a parameter to see it reflected on the map. We can also view DD5 in 2001 to 2020. To see the change in the data from the reference period 1961 to 1990 to 2001 to 2020, click on Show Calculated Difference from Reference Period. To see the percent change in the data from the reference period to 2001 to 2020, click on Show Percent Change from Reference Period. Let's look at simulated data. Choose the GCM and the SSP. Let's use SSP 245. We can view what the data is projected to be between 2021 to 2040 and show the calculated difference from the reference period and the percent change. We can view what the data is projected to be farther in the future between 2061 and 2080 and show the calculated difference from the reference period and percent change. Going back to observed data, let's look at precipitation as snow, abbreviated as PAS, in the winter during the reference period 1961 to 1990. Now let's view 2001 to 2020. We can view the calculated difference and the percent change. Let's look at simulated data. Choose the GCM and the SSP. Let's use SSP 245 again. We can view what the data is projected to be between 2021 and 2040. We can show the calculated difference from the reference period and the percent change. We can view what the data is projected to be farther in the future between 2061 and 2080. We can show the calculated difference and the percent change. Click on Download Downscaled Data to download the zipped GeoTIFF file. In our next video, I will show you some quick tips for troubleshooting in the Get Data tab.